I'm sharing my screen now, so please let me know. Just wait.
Yes, sir.
I have shared my screen. So can anybody tell me, is my screen visible or not? Anyone, please? I have shared my desktop screen. So is the screen visible? Yes or no?
Yes, sir. Visible. Yes, sir.
Okay. Fine. Thank you. Thank you for your feedback. So let me start sharing my presentation here. Is this presentation visible? Hello? Hello? I have shared the presentation. Is it visible to you? I have started presentation.
Yes, sir.
Okay, fine, fine. So now these are your technical, these are your skill or the professional training kind of lectures. So through these lectures, we are actually trying to aware about some of the technical terminologies or some of the technical trends in which you may either go for your final year projects or these technical things are very much important for you as far as electronics and telecommunication engineer is concerned. Okay, so today I'm going to teach you about the advanced design system software, which is pretty much useful for microstrip patch antenna design. Okay, so basically ADS is not just used for this microstrip patch antenna design, but it is a very huge software and it can be used for many other purposes. Okay, for RF design, RF circuit design, it is useful. So before starting with ADS, these are some of the alternative microwave tools which are available in the market. Okay, and how I have categorized them. So it is categorized based on their computational methodologies. So what are these different computational methodologies? If you could see finite element method. Let me take here the pen. Yeah. So it is finite element method. These are the computational methodologies, and these are some of the softwares like HFSS, Ansoff software, eField, FECO, COMSOL. So all these softwares are based on this computational methodology, which we named as FEM, that is finite element method. Okay, so a lot of softwares, simulation softwares are available in the market if you wanted to simulate RF circuit design. Okay, then based on MOM methodology, that is method of movement. Okay, some softwares are there. Same FECO is used here. So FECO is having both methods, FEM as well as method of movement. Okay, and it is some more softwares like IE3D, Sonnet, okay, Super NEC. So IE3D is a very popular kind of software which people are using these days. Then based on FIT method, that is finite integration techniques method, the CST software is useful. It is once again a kind of software which is most of the researchers and students are using these days. So it is actually using the finite integration techniques as a computational technique. Then based on this FDTD, that is finite difference time domain method. Some of the softwares are there like eField, Fidelity, James, SynCAD. Okay, so these are some of the softwares which are actually using FDTD as a computational methods. Okay, and all these techniques are useful. All these techniques are useful for RF circuit design simulation. For what purpose it is useful? RF circuit design simulation. Okay, so I am telling these things for these are actually the alternatives of ADS. Okay, if you see I3D, so it is using the method of movement. Okay, and it is mostly useful for circular and rectangular kind of antennas. Okay, those who are having smaller structures, okay, or the simpler structures. Okay, it gives you more accurate result than HFSS. Okay, Zeal and Fidelity software is there, which is using this FDTD, and it is for DRA kind of antenna. Okay, the resonator antenna or dielectric resonator antenna. Then HFSS software is there, which is using FEM, mostly for small structures. Okay, for complicated structures, we may use IE3D software. Then CST. So based on our need and the kind of facilities that our college is having or the institute is having, these softwares are actually useful. Okay, so every software is having its own pros and cons. Like IE3D is mostly useful for simpler structures, and HFSS is actually useful for smaller structures, and for complicated structures, IE3Ds are useful. Then for complicated structures, CST is also useful. HECO is there for the larger structures, and ADS, which we are going to study today, it is useful for all of the RF circuit designs. Means it can covers all the actives and passive circuits, components, antennas, all of the things. Okay, and what sort of computational method it is using? It is using method of moment as well as finite element method. So if you can see, two computational techniques are used, just like in I think in IE3D. IE3D mostly uses method of moment, but if you see ADS, it is uses method of moment as well as finite element method. Okay, so that's why this ADS is having its huge demands, and we can simulate almost all of the things, RF circuits, all antennas, all of the things in this ADS software. Okay, so let us start with this ADS software. What is this ADS? That is Advanced Design System Software. So basically, ADS, that is Advanced Design System Software, it is an electronic design automation software for RF, microwave, and high-speed digital applications. This ADS software provides standards-based design and verification with wireless libraries and circuit system simulation in an integrated platform. So basically, it is giving you, or it is actually the kind of platforms which will provide you different wireless libraries where you can do your circuit simulations and other things like antenna design simulation. Okay, ADS have advanced capabilities that helps in the design process before fabrications of wireless components such as power amplifier, RF front-end module. So basically, as I said earlier, like RF frequency, RF design components like power amplifier, uh, some other RF components are there, which we can design with the help of this ADS software. Okay. It allows you to create, analyze circuit and system design and display the simulation data. Means with the help of this software, we can do the analysis of a particular RF circuit design or antenna design. So for that, we can create the design first, then we can after creating the design, means after making the design, we can simulate it, and once the simulation has been done, we can display the result. Okay, so this software is useful to display, means whatever the results that we wanted, that can be simulated with the help of this software, that is AV. Okay, so just a minute. Coming. Laptop is got hang, I think. It's not working right now. Just hold on. These are not working actually in my laptop. I think it got hang. Hang on for a moment. The presentation is not working properly. So once it is properly working, then I will get back to you. Hang on. Okay. Uh, I'm going to open the presentation again. Please let me know whether this presentation is visible to you or not. So I don't know how it is. Anyway, we will start it once again. Okay, so can anybody tell me, is this presentation visible to you or not? Yes, anyone? I have started, I have opened this presentation again. So please let me know whether this presentation is visible to you or not. Anybody?
यस सर दिख रहा है.
Okay, okay. Thank you very much. So, okay, so let us continue now. I think now we let us go to now ADS main window. So whenever you are going to open the ADS software, sorry for this disturbance. Uh, so whenever you are going to open the ADS software, then this screen is the first one which is going to appear in front of you. Okay, so we call this as an ADS main window. Okay, this is the ADS main window. It's having different versions available. I'm having 2014, 2011 version with me. Right now, 2017, 18 versions are also available. 2020 version is also available. So, and even our college is having this advanced design system software facility available in our lab, communication engineering lab, and we are also having vector network analyzer. Okay, so we are having all sort of functionalities, all facilities available with us. Now let us have a look on this ADS. So basically, this ADS is having some parameters, some features, like it provides different resources like built-in library components, third-party libraries are there. You can interface this with the another tools. Then some design guides are there. Okay, some of the entry tools, design entry tools like schematic design is there. Layout design means you can build up your circuitries through schematic or through layout. For example, suppose if you wanted to, let's say, design an antenna, then in the schematic window you can design the antenna, or in the layout window also you can design the antenna. Okay, so both of the functionalities tools are available. Some of the verification tools like desktop LBS, DRC, these things are available. Now, some of the components of ADS. Okay, some of the simulation tools like circuit simulator is there, electromagnetic simulator, DSP simulator is there. So this circuit simulators are basically useful for DC, AC, S parameter and transient analysis. Okay, for transient simulation. Some visualization tools like data display, 3D viewer, physical connectivity is there. Okay, and some product design tools which we are not that much useful, but mostly we are using this circuit simulators and all. Okay, now let us come to the actual uh, overview of this ADS. Okay, so now from here onwards, I am going to tell you about how this software is going to be work, or how to handle this software. Okay, so let us getting started with this ADS. So once you open this software ADS, this kind of screen is pop up. Okay, at first. Now let us let us looking at the workspace. Okay, so before building up the design, you will have to create the workspace. Okay, so when you open this ADS software, you will have to first of all create the workspace, and in the workspace, then the rest of the things you can do like you can build up the designs, you can do the simulation, you will get the results which can be viewed in this workspace. So everything can be stored in the workspace. What basically is this workspace? It is the multi-technology project that has its own library of design component, and references to component libraries is called as a workspace. Okay, so basically how to open the workspace, right? How to create the workspace. So to create the workspace, workspace can be managed from getting started window. Okay, so once you open the ADS software, from the started window, you can create the new workspace. Just while clicking here, create a new workspace, your new workspace will be created. If suppose you have already done some task, then that task can be open, means you have already created the workspace, so that can be open from here. Okay, so this kind of things are there. Now, listen, this is actually the kind of window which will be there in the ADS. Now, how to open the new workspace or to create the new workspace? So for that, if you see the first icon, 1 minute, let me take the pen. Okay, so if you see this icon, W plus, this is useful for creating the new workspace. Means if you wanted to create the new workspace, you just click over this icon. Okay, and now if suppose you wanted to open the existing workspace, then this icon is useful. Very simple. So once you click over this icon, your new workspace will be created. Now how it looks like? So this workspace is, let us have a look on this workspace, like how it is, what exactly is this workspace. Okay, so basically it will assist you in creating the new ADS workspace, where different things are there, like libraries, external libraries, simulation data, data display files. As I said earlier, all these things are available in this workspace. Okay, it contains library, then it is having simulated data, data display files are there, okay, and other files also. So once you click over the next, now how to create the workspace. Okay, so once you click over this next, okay, next, then you need to write the name of the workspace. Any name you can given. Remember, you don't need to provide any space. Okay, it will not accept any space, so you can provide any name here, and then the some destination. Okay, you will require some destination, like the path you can provide from here. Okay, and then click over the next. So in that particular destination, this file will be stored. Okay, so once you click over the next, now the next will be like what sort of libraries you require. So these are some of the by default libraries, like ADS libraries, analog DSP libraries you can select. Okay, or they are by default available there. So you just click on the next. Okay, now once you click on the next, the library name you need to create. Okay, library name. So probably the workspace name that we have written, same name you can give it to the library. Okay, not necessary, but you just to avoid the confusion, the library name and workspace name will be same. Okay, now once the library is created, then you need to look up for the technology. Okay, मतलब इसके बाद आपको technology select करनी पड़ती है. Then there are different technologies. This is mostly for लेआउट डिजाइन, नॉट फॉर स्कीमेटिक. देखो दो तरह के डिजाइन बनते हैं एडीएस में, एक तो स्कीमेटिक लेआउट या एक तो स्कीमेटिक डिजाइन या फिर लेआउट डिजाइन. ओके, तो लेआउट डिजाइन में क्या करते हैं, हम लेयर्स को बना के मतलब हम डिजाइन बनाते हैं. तो फॉर दैट पर्पज विल हैव टू लुक अप फॉर दिस technology, like is it 0.0001 milli, it is all about distance. Okay, या मिलीमीटर लेना है आपको, माइक्रोन लेना है, आपको कौन सी टेक्नोलॉजी लेनी है, मतलब माइक्रोमीटर टेक्नोलॉजी, मिलीमीटर टेक्नोलॉजी या मिलीमीटर टेक्नोलॉजी या मिली टेक्नोलॉजी, माइल्स टेक्नोलॉजी. ओके, so that you can use. Mostly we can prefer millimeter layout resolution, 0.0001 millimeter, second one. Okay, so once I come to the original software, then you will get to know how exactly these technologies are useful. We will see this little later. This is just the introduction part now. Okay, now once we click over the next, then everything will be done. Your workspace will be created and your libraries are also created. Okay, so this is all about the workspace. So this way the workspace is created. If you can see, this name is visible, like its path, and this workspace demo underscore one. Okay, so this workspace is created. Now under this workspace you can simulate, you can create the schematic window or layout design window or this symbols. Okay, so let us go into the next part, that is how to create the cells of the views. So what is the cells? 1 minute. Got hangs again. why this presentation is not working properly. Now the cursor is working. This presentation. Anyway. One minute. My system is hang actually. Presentation cover hang होता क्या नहीं? I don't know why. It's not supposed to be hang. I'm sharing it again. Okay. Sorry for this. I don't know why this is happening now. It is continuously getting stuck at one place and got hanged. Anyway, so where were we? Actually, we have created the workspace. Then we have created the library inside it. Now, once your workspace is created now, then inside that you can do the simulation. Like you can make either your schematic design or the layout design or both of the designs possible. And once you have made the design, then you can simulate it. Okay. So I think where were we? Workspace is over. Uh, okay, cells and views, right? So as I said, cells and views. So this is basically ADS main window. This is the what the workspace we have created. If you see, this is the workspace we have created. Now out of these three icons, schematic, layout, and symbols, we will have to use any one. Okay, schematic, layout, or symbol and model. So out of these three, we can choose any one. Let's say, suppose for example, we have used schematic window. This first icon. This first icon. So it is a schematic, new schematic window. Just give the name, uncheck this in it, and then press OK. Okay. So your new schematic will be created. If you see with this name, schematic, you can give any name, whatever you want. So now in this schematic window, okay, how the schematic window is looking like, I will let you know little later because this is not a software, it's a presentation. I will let you know little later how the schematic window is looking like. Okay, now if you click over this middle icon, it is actually giving you the layout window. Okay, where you can build up your layout design. And if you press over here, this symbol, these are actually useful to create the symbols and design. Okay, so yeah, this way your layout and schematic files will be visible inside the library. Okay, and inside this layout design or schematic design, you need to simulate your antenna design or any RF circuit design. Okay, now these are some of the visualizations which are appearing on that screen, either on the schematic window or the layout window. So menu bar and a lot of options are there. Okay, if you see this, all these options are you can use this once this software is you are familiar with the software, then these are all the options very much useful just to make create just to create the design and just to make the modifications in the design. All these sort of menus are available. Okay, so like if you wanted to copy and move the design, then this icon is useful. Then yeah, to delete, this icon is useful. Then to open, new, save, print, these four icons are useful. Okay, first four icons are useful. So a lot of things are there. Okay, we are not looking much more to that. Okay, this is the kind of bit library category. Means if you wanted to pick some of the components, okay, some of the circuit components that can be, you can pick it from the lump component. Okay, so on this menu bar, there is a lump component name. Once you click over that, some the library in which all of these components are available. Once you get that, you just have to drag and drop it into the schematic window. Okay, from where you wanted to build up your schematic design. Okay, then yeah, these are the pins, grounds, all that can be useful to provide over the design. Okay, all these wires and all that. Okay, this is actually the kind of icons which is helpful to run the simulation. Okay, directly you can run the simulation with this help of icon. Once you click over this icon. Okay, and then this bottom bar that is actually giving you the means once you know move this cursor accordingly the locations will be changed. So it is just telling you the dimensions. Okay, the coordinates of the cursor when it is moved. Okay, yes, mouse location. So and then finally here you will create your circuit. So this is basically the schematic layout or schematic design window where you can build up your schematic, okay, or any circuit design. So circuit to be implemented here means you can drag and drop this element here. You can connect them with the help of this, wire. You can provide an input supply means with the help of this P. You can provide ground connections from here like. Okay, so this is all about schematic windows. Okay, same is for layout window also. Now, as I said earlier, like our heading, our aim is to simulate the microstrip patch antenna design with the help of this ADS software. So I am considering you at least know what exactly is the microstrip patch antenna. Okay, so in short, I am going to tell you microstrip patch about the microstrip patch antenna. So microstrip patch antenna is basically the antenna which is composed of three things. Okay, three things. The first is this patch. Okay, or I would say the first is the substrate material. Okay, a substrate material which is having certain permittivity, some thickness, some loss tangent. So you must require first of all a substrate material, and now the substrate is having top portion and the bottom portion, right? So to the top part of the substrate, we are going to print some conducting material over the top part of the substrate. Or actually, there are some substrates which are available in the market which are having uh, on the top part of it conducting material is there, on the bottom part of it conducting material is there, and in between this substrate dielectric part is there. Okay, so basically microstrip patch antenna is an antenna which is composed of three things. Okay, I can say two conducting materials at the top and bottom, and in between these two the dielectric material is sandwiched. Okay, so in between the two conducting material, like top conducting material and the this is, if you see this white part, it is a top conducting material. Okay, and this black shaded portion, it's a, if you see this side view, okay, this is the conducting part, top part, this is the bottom conducting part, and in between it's a dielectric material. This all is called as a microstrip patch antenna. Now this top part you may design by your own way. Okay, it may have any sort of shape, just like here the rectangular shape you can see, and it is fed by the microstrip feed line. It is an inside feed line. There are different types of feedings used to feed the microstrip patch antenna. And similarly to the ground, you may use different types of shapes and all. There are different types of things like finite ground plane, infinite ground plane. Okay, different types of ground planes you may use. So this is all about the microstrip patch antenna, and this patch antenna design will have to create in the ADS software and will also have to simulate. Okay, so now before doing the simulation, how the simulation and data visualization is there, let me tell you here. Okay, so if you wanted to do the simulation, okay, if you wanted to perform the simulation, then as I said earlier, like you just directly need to click over this icon and your design will get simulated. But before doing the before clicking over this, you need to build up the circuit, right? So to do that, first of all, I need to open the ADS software. Okay, and this is about data display window. So once your simulation is done, and once it is run, then whatever the results you will get, to to visualize that result, you require a data display window. Okay, and this data display window is having multiple features, so we may use this. Okay, so I'm not going to tell you much more details about these things because you will not getting things, any of the things right now for this moment. let me directly comes to the ADS software, and I will let you know how to do the circuit, how to do the antenna simulation. So I am going to, design a microstrip patch antenna here. Let me minimize this. I am going to design a microstrip patch antenna that can be resonate over the 2.4, that can be resonate at 2.4 gigahertz frequency. Okay, and we'll try to get the results of it. Okay, so if you see, I am having this advanced design software with me of 2014 version, and I have already opened it in my computer. So as I said, like, this is the uh, first window you will get. You can, okay, what I do, I will close this first. Okay, I can start it right from the start. Okay, okay, so now I am having this icon. I can double click over it. Okay, so it will start opening now. So once it's get open, now this type of window, this type of pages pop up. Okay, so here you will have to select what sort of environment you require. So we require ADS design environment here. Okay, first options we can select. So I can click OK here. Different types of environments are available. We are going to use the design environment here just to do the design. Now, if you see, first of all, we need to, create the library and workspace and library. So how to create the library workspace? So as I said, you need to click over this icon, or even if you click over file, then new, and then workspace, then your workspace will be created. Okay, so let me click over this icon, create new workspace. Okay. So once I click here, then it is asking me, it is just providing some information like what exactly happening out there in the workspace, or what is there in the workspace. Okay, like it is having different libraries, simulation data, some display simulated data. Then once we go get the result, then that result data also available there. Okay, so let us click over the next. Okay, and let us give now the name to this workspace. So which name I am going to give? Let's say microstrip patch antenna design. Okay, microstrip patch antenna design 1. So I have given this name as MPA design 1. Okay, and the same name I am going to give it to the library also. So if you see, this is what the path I have given where the workspace will be stored. Okay, then next. So these are the libraries by default, it is there. Okay, so we just select as it is and then click over the next. Okay, you can add your own libraries too from the external sites also, but since these libraries are already there, so we can use them. Okay, if suppose some libraries are not available in this software, you may import them from the external site. Okay, then next. So same library name I can use as like the workspace. Okay, and then click over the next. Okay, next. Now once you click over the next, then they ask you to choose the technology. So as I said, we are always looking for the millimeter technology, means millimeter layout simulation, layout design. You may use mil or micron or any other thing. Okay, here I am using millimeter, and then click over the next. Okay, so everything is created now. Workspace is created, library is created, and the technologies also has been defined. Okay, so finish. Now once you click over the finish, now you see. Uh, so if you see now, this workspace is created and the library is also there. Okay, so in this workspace, we will have to now do the simulation, or we'll have to create the design. Okay, so now let me how to create the design. So as I said, these three icons are useful. Okay, this is the schematic window, this is the layout window, and this is for symbol creation. Okay, so we are going into the schematic window. Okay, now let me click over the schematic window here. Yes, now we will give some name to this schematic window. Let us as it is. Okay, scale 1. We can deselect it. Okay, so cell 1 is the name of the schematic window, and click over OK. So once you click OK, now this is your schematic. Okay, so this is your schematic window. Now here in this window, we are going to create our own design, and we will simulate. So which design we are going to create? We are going to design the microstrip patch antenna that will be resonate at 2.4 gigahertz. Is that clear? Okay. So what we can do now, one by one. So since I don't need this element. I need a microstrip patch antenna element. So for that, I can use microstrip. You can use this microstrip transmission lines. Okay. So if you see this transmission line microstrips, I can use this. Under this now library, we are having different elements available. ओके तो देखो हम सबसे पहले एक एक एलिमेंट ले लेते हैं लेट अस टेक द फर्स्ट एलिमेंट सो आई एम क्लिकिंग हियर एंड ड्रैग इट टू द विंडो ओके सो ये हो गया हमारा पहला ये है हमारी फर्स्ट ट्रांसमिशन लाइन यू नो द माइक्रोस्ट्रिप पैच एंटीना जनरली से इट इज मेड अप ऑफ द different transmission line okay so let's say this is our first transmission line why I have created taken this as an open circuited microstrip open transmission line let me tell you a little later. Then I need one more microstrip transmission line. Okay, so two transmission line I have created. This transmission input transmission line means it is for the purpose of I wanted both input and output for the transmission line. So this can be used as a feeder. Okay, it can be used as a feeder to the microstrip patch antenna. So this is basically our microstrip patch antenna. And to fit this microstrip patch antenna, we require a transmission line. So I have used this transmission line. Okay, and now we wanted to provide some power supply to this patch antenna through this feeder. So for that we are going to use a pin. Through this pin supply, we can provide the power to the microstrip patch antenna. Okay, so that's it. You can just escape it. Now we will have to make the connections in between these three elements. So with the help of this wire, you can see with the help of this wire we can connect. So now I am going to connect all these components. Okay, so this is how this can be uh, connected. Okay, so now from here we are not getting like how exactly our antenna is looking like. Okay, so first of all let me choose the length and width of this components, and then after that we will go to the layout window where we will exactly get to know how our microstrip patch antenna is looking like. Okay, so now what will be the length and width? So listen, it depends upon for what kind of frequencies you wanted to design your antenna. So it depends upon the frequency where your antenna is resonating. Accordingly, length, width parameter will be varying. And not just this frequency, there are many more parameters which will be deciding the length and width of the microstrip patch antenna. Okay, so right now I am not going to tell you like how to choose the values of length and width of the microstrip patch antenna. There is a calculator also available in this software from where you can directly calculate the length and width of this microstrip patch antenna or feeder length and all. Okay, so we'll directly choose the length and width of this microstrip patch antenna as well as this feeder. Okay, so let me take the length. 1 minute. Okay, so first of all, I am going to provide the length and width of this microstrip patch antenna. So the width I am going to provide as let's say 35 mm, and the length I am going to use it as 29 mm. Okay, 29 mm. Or let's say suppose I am using it as suppose 25 mm. Okay, 25 mm लेता हूँ बाद में देखेंगे कि सच में वो frequency पे resonate होता है या नहीं. So now we have used a microstrip patch antenna design which having the length 25 mm and width 35 mm. It's a rectangular microstrip patch antenna which having 25 mm length and 35 mm width. Now we are going to design a feed lines with the length let's say width let's say 2.9 mm, 0.9 mm, and the length is 10 mm. Okay, listen, this to design this feeder or the microstrip patch antenna, deciding the length and width is very important, and there are many more parameters which are there to calculate this. Okay, there are some equations and all that, so we are not going into the analytical part. Okay, so I have selected length and width of the feeder as well as this microstrip patch antenna. Now let me try to observe this microstrip patch antenna, like how it looks like in the schematic, in the layout design. So in the layout we'll exactly get to know how the antenna is looking like. Okay, so what I can do now, I'm using this layout, so I'm clicking over the layout and then click over generate or update layout. Okay, so once you click over generate or update layout, okay, and then here press okay, so your layout has been generated. Now this is how your antenna is looking like. This is how your antenna is looking like in the 2 dimension. हाँ, इसको मैं 3 dimension में भी आपको दिखा सकता हूँ, ये अभी 2 dimension में, ठीक है। सो ये देखो, ये आपका माइक्रोस्ट्रिप पैच है, देन ये आपका फीडर है, फीड लाइन है, राइट, एंड ये छोटा सा पिन है, वहां पे छोटा सा पिन जहां से हम पावर प्रोवाइड करेंगे। जस्ट अ मिनट, जस्ट अ मिनट, हेलो, हाँ मिनट। Okay, so now I think this pin is not properly visible. So if you zoom it, you will get to know how this pin how the pin is looking like, or whether it is appearing or not. So I think it is not yet there. Yeah. So if you can see now, after zooming it, this pin is available and it is very well connected to this feeder. And this is what the microstrip patch antenna. Okay, I have zoomed it. So if you click here, it is visible. The complete structure is visible here now. Okay, how it looks like in a 3D structure, let me tell you here. Okay, in a 3D structure, how it looks like. So if you need to click over this icon, that is 3D EM preview. 3D EM preview. Okay, so I think 3D view. 3D EM preview is after simulation. Okay, 3D view को देख लेते हैं हम इसको. हाँ सही है. 1 मिनट. हाँ, आई थिंक हमने ये क्या किया है, सिर्फ पैच एंटीना डिजाइन किया है. अभी तक हमने सबस्ट्रेट को डिजाइन नहीं किया है, क्योंकि सबस्ट्रेट रहता है, राइट. द सबस्ट्रेट इज देयर and above the top part of the substrate is having this microstrip patch antenna along with this feeder and connector, and we'll also have to provide the ground plane to the substrate, right. तो अब हमारा नेक्स्ट स्टेप क्या है, टू डिजाइन अ सबस्ट्रेट. तो देखो, अब सबस्ट्रेट को डिजाइन अगर करना है तो आपको कहाँ पे जाना पड़ेगा, सबसे पहले क्लिक करना पड़ेगा EM पे, and then you need to click over the simulation setup. कहाँ पे, simulation setup. So once you click over the simulation setup, आप देखो यहाँ पे आ गए हम. यहाँ से हम क्या करेंगे, सबस्ट्रेट प्रोवाइड करेंगे. सो यू नीड टू प्रोवाइड सबस्ट्रेट फ्रॉम हियर. सो क्लिक ओवर द सबस्ट्रेट. चलो ठीक है. अब देखो यहाँ पे कोई सबस्ट्रेट अवेलेबल है क्या, फिलहाल नहीं है. तो मैं क्या करता हूँ, न्यू पे क्लिक करता हूँ. ओके, लेट अस गिव द नेम, लेट्स से सबस्ट्रेट 1 व्हाटएवर. ओके, एंड देन क्लिक ओके. अब देखो ये जो है ना सबस्ट्रेट, इसका हमें क्या करना है, वैल्यू लिखना है. तो अब हम ये सबस्ट्रेट बना लेते हैं सबसे पहले. तो यहाँ पे ऑलरेडी एल्यूमिना मटेरियल है, हम एक नया मटेरियल बना लेते हैं. ओके, सो ऐड डाइलेक्ट्रिक मटेरियल. ओके, ये डाइलेक्ट्रिक को लगे तो हम नाम देते हैं, लेट्स से FR4. जनरली FR4 substrates are used for the microstrip patch antenna design, flame retardant substrate. Now it is having certain permittivity. So let's say it is having the permittivity 4.3. It is having standard permittivity and loss tangent 0.0. Okay, loss tangent value 0.03. So permittivity we have provided, loss tangent we have provided. Now from here we will have to select that. So that is FR4. Okay, alumina air नहीं लेना है, FR4 which we have created by our own. So हमने ये FR4 substrate डिजाइन किया है. हाँ, इसकी जो थिकनेस रहती है FR4 substrate की, ये रहती है 1.5 mm. 1.5 mm. So अब देखो यहाँ पे ये जो दिख रहा है ना आपको, 1.5 mm की थिकनेस दिख रही होगी FR4. ओके, 1.5, हाँ मिली नहीं, mm लेना है हमें, मिलीमीटर. ओके, सो इट्स 1.5 mm. देखो ये FR4 सबस्ट्रेट है जिसकी हाइट कितनी है, 1.5 mm थिकनेस. ये ऊपर का पैच है और नीचे का ग्राउंड. ठीक है, अब ये पैच तो हमने डिजाइन कर दिया है, और ग्राउंड हम इनफाइनाइट ले लेंगे. यहाँ पे कोई इसको फाइनाइट भी बना सकते हैं, बट लेट इट बी फॉर नाउ, इट इज अ इनफाइनाइट ग्राउंड प्लेन. Okay, so everything is there. Now let us save it and close it. Okay, so save and now close it. So we have created a substrate. ठीक है, जैसे ही हमने substrate बना लिया है, now everything is ready for the simulation. अब हम simulation कर सकते हैं. Okay, before doing the simulation, let me try to visualize this antenna in the three-dimensional space. So I am clicking here 3D. अब देखो आपको 3D में कैसे पैच एंटीना दिखता है. 2D में मैंने आपको दिखाया है, राइट? ये देखो, ये आपका 2D में दिखा है एंटीना, अब इसको ही आपको 3D में दिखेगा. हाउ द एंटीना पैच एंटीना इज लुकिंग इन अ 3 dimension. Need to wait for some time. It is loading. It is loading. So this ADS tool is a very beautiful tool which will be giving you the visualization in 3 dimension. Okay. So now it is loaded. हाँ, okay. अब देखो मैं इसको क्या करता हूँ, मैं इसको Z स्केल पे लेता हूँ. ठीक है, थोड़ा सा हाइट बढ़ा देता हूँ उसका, थोड़ा सा हाइट बढ़ा. हाँ, अब देखो ये आपका जो पैच है, दिस इज योर सबस्ट्रेट. हैव अ लुक. ये आपका सबस्ट्रेट है, दिख रहा है आपको सबस्ट्रेट? सबस्ट्रेट का ये जो ब्लू पार्ट दिख रहा है, दिस इज कॉल्ड एज अ ग्राउंड प्लेन. ये क्या है? आपका ग्राउंड प्लेन है. ये ऊपर का जो दिख रहा है, इट इज योर पैच एंटीना. फीडर भी उसको कनेक्टेड है, और ये देखो पोर्ट कनेक्ट किया है ग्राउंड से. राइट फ्रॉम हियर वी आर प्रोवाइडिंग पावर सप्लाई टू दिस एंटीना. सो दिस इज द माइक्रोस्ट्रिप पैच एंटीना वी हैव डिजाइन. ठीक है, ये हमने रेक्टेंगुलर माइक्रोस्ट्रिप पैच एंटीना डिजाइन किया है. ये 3 डायमेंशन में दिखता है. ठीक है, अभी इसको हम रन करके देखते हैं कि वेदर इट इज. इसको मैं क्लोज कर देता हूँ अभी. ओके, अब इसको हम क्या करेंगे, सिमुलेट करेंगे एंड देखेंगे कि वेदर इट इज रेजोनेटिंग ओवर 2.4 गीगाहर्ट्ज फ्रीक्वेंसी और नॉट. ठीक है, तो लेट मी सिमुलेट इट नाउ. तो कहाँ पे गया वो आइकॉन, मैंने आपको जो बताया था. सो वेयर इज दिस आइकॉन? कहीं पे. ओके, मैं ईएम में जाके सिमुलेशन ये बोल सकता हूँ. ठीक है, अगर आपको आइकॉन नहीं दिखेगा तो आप क्या कर सकते हो, ईएम पे क्लिक करके सिमुलेट या F7 प्रेस कर सकते हो, वो सिमुलेट हो जाएगा. ठीक है, अभी अरे हाँ 1 मिनट. हाँ, हमने इसको सिमुलेट करना तो है. 1 मिनट. इसको डायरेक्ट नहीं सिमुलेट करना है. देखो हमने लेआउट बनाया है, राइट? हमने सबस्ट्रेट दिए है, देन हमने पोर्ट्स भी डिजाइन किए, पिन्स दिए है. हमें एक फ्रीक्वेंसी प्लान चाहिए. जैसे हमें कौन सी फ्रीक्वेंसी पे इसको देखना है, तो अब हम इसको क्या करेंगे, 1 गीगाहर्ट्ज टू 3 गीगाहर्ट्ज पे रन करेंगे, क्योंकि हमें एक्चुअली 2.4 गीगाहर्ट्ज फ्रीक्वेंसी पे इसको ट्यून करके देखना है, राइट? सो मैक्सिमम 1 टू 3 गीगाहर्ट्ज. जितना फ्रीक्वेंसी ज्यादा होगी उतना टाइम ज्यादा लेगा सिमुलेट करने. तो लेट अस नाउ डू द सिमुलेशन. एस पैरामीटर को जनरेट करना है. देखो यहाँ पे लिखा है एकदम बॉटम पे, देखो क्या लिखा है, जनरेट एस पैरामीटर. तो हम एस पैरामीटर को देखते हैं. ओके, so now I have run the simulation. ओके, मैं इसको स्टॉप करके फिर से रन करता हूँ. ठीक है, जॉब अबॉर्टेड. ओके, इसको फिर से मैं सिमुलेट करता हूँ. ठीक है, ये थोड़ा सा डिले हुआ. ओके, ईएम पे क्लिक करेंगे एंड देन सिमुलेशन सेटअप में जाएंगे. देखो फ्रीक्वेंसी प्लान ऑलरेडी हमने दे दिया है 1 गीगाहर्ट्ज टू 3 गीगाहर्ट्ज, राइट? Layout we have created and substrate we have also created. Port we have also provided, and frequency plan like 1 to 3 gigahertz because we wanted to resonate. We wanted an antenna that will be resonate over 2.4 gigahertz. Means we are testing our antenna for 2.4 gigahertz. So now simulation. So yes, now it is simulating. Okay, so let's see whether our antenna is going to resonate at 2.4 gigahertz or not. If it is not, then we'll have to change the length and width of the microstrip patch antenna. Let's see how it is going. So I have run the simulation. It will take some time to simulate. So don't go anywhere. Within 5 minutes, we are trying to finish this. Every parameter is calculating for almost 1 gigahertz to 3 gigahertz frequency. All as parameters. अब as parameters क्या रहते हैं? I think a lot of fundamentals that I need to teach you if suppose you. Anyway, हमें ADS के साथ familiar होना था, कैसे करना था, थोड़ा बहुत मैंने बता दिया. अब देखो ये कौन सी frequency पे resonate हो रहा है? It is resonating at 2.9 gigahertz, which we don't want it, है ना? ये 2.9 gigahertz पे resonate हो रहा है. देखो, it is coming to the 2.9 gigahertz. -10 dB रिटर्न लॉस से कम चाहिए हमें. ठीक है, तो -10 dB रिटर्न लॉस मतलब क्या होता है कि ऑलमोस्ट 90% पावर इज गिवन टू द माइक्रोस्ट्रिप पैच एंटीना, ओनली 10% लॉस इज देयर. ओके, सो दैट्स व्हाई -10 dB स्टैंडर्ड रहता है. सो इट इज रेजोनेटिंग एट 2.9 राइट नाउ, व्हिच वी डोंट वांट इट. वी वांट इट समवेयर एट 2.4 गीगाहर्ट्ज. इसका मतलब क्या है कि हमें क्या करना पड़ेगा, हमें हमारा एंटीना का जो डिजाइन है, ओके, it is in progress, I think. 1 minute. Okay. So हमें क्या करना पड़ेगा, हमारा जो एंटीना है उसकी लेंथ एंड विड्थ चेंज करनी पड़ेगी. ओके, तो अब हम इसको रिलीज करते हैं, लेंथ थोड़ी सी चेंज करके देखते हैं. ठीक है, तो वेयर इज आवर स्कीमेटिक विंडो? हियर इज आवर स्कीमेटिक विंडो. सो नाउ आई एम गोइंग टू चेंज द length of this microstrip patch antenna, which was before 25 mm. Now I am going to increase it to 29 point, let's say 8 mm, 30 mm almost. Okay, इसको मैं सेव कर देता हूँ. अब इसको मैं इसका लेआउट डिजाइन कर लेता हूँ. पहले जनरेट लेआउट. चलो, इसका लेआउट डिजाइन हो गया. अभी इसको मैं सिमुलेट कर सेम फ्रीक्वेंसी में. ठीक है, अब देखते हैं कि वेदर इट इज रेजोनेटिंग एट 2.4 गीगाहर्ट्ज और नॉट. 2.9 गीगाहर्ट्ज पे पहले रेजोनेट हुआ था, अभी हमें 2.4 पे चाहिए. हमने लेंथ को बढ़ा दिया है 25 mm से 29.8 mm तक. लेट्स सी वेदर इट इज सिमुलेटिंग रेजोनेटिंग एट 2.4 गीगाहर्ट्ज और नॉट. You know for what purpose 2.4 gigahertz frequency is useful? I think mostly we are using Wi-Fi, Bluetooth applications like. So Wi-Fi, Bluetooth, all these are actually the kind of applications which are working over 2.4 gigahertz frequency. What does it mean? The antenna that we have designed, it can be useful for which application? Wi-Fi application. Is that okay? So it is useful for Wi-Fi, but it must be resonating at 2.4 gigahertz frequency. Let's see whether it is resonating at 2.4 or not. Okay, so it is running. It is giving us the return loss S11 parameter. Yeah, so now I am going to maximize it and zoom in. Okay, so if you can see now, it is somehow resonating at 2.42 or 2.43. Okay, you may place marker over it, and let me place a marker. Okay, anyway, so it is somewhere. देखो यहाँ पे दिख रहा होगा आपको फ्रीक्वेंसी. इट इज 2.429, almost near about 2.4 gigahertz frequency. Where our S11 is, I have placed here the cursor. It is giving us the S11 value which is more than -10 dB. So this is what the kind of results which we wanted. So this is what the final result. So this is all about this ADS. We have simply designed here the microstrip patch antenna that is resonating at 2.4 gigahertz, and that can be used for the wire